Okay, let's do some math. 5.2. We're on the cubes still. Let's see what we got. So an artist paints several cubes of various sizes. One cube is 20 by 20 by 20. Which expression represents the number of blocks with one painted face? Okay, so the ones with one painted face were these guys, where it was just n-2, but it was a square of them, so I expect it to be squared, and then it was on 6 faces. So that was the formula. And if we're going to let n be 20 in this case, then it's looking like that one. Okay, let's keep going. Which size painted cube has 300 blocks with 2 faces? So 2 faces were these edge pieces that were 12 edges in the cube. And we were going to have n-2 of them, because again, remember, we always have to subtract 2 to get the corners out of there. Okay, so that's this. Oh my gosh, look, the formulas are right here. Okay, all right. I see it now. Either way, though, we can figure it out without it. 12 times n-2, and this is the number of blocks. Now, in this case, we are told the number of blocks is 300. So we're going to throw 300 here, and then we're going to have to solve for this. And there are a couple ways. We could use the pattern, the stuff that we learned in 5.3. If you want to distribute the 12, you can. I think that's more straightforward for a lot of you. However, personally, I see this as 12 times something. So I want to divide the 12 and get rid of it. Make my life a little easier right from the start. 12 goes into 30 25 times. I'm sorry, 12 goes into 325 times. 12 goes into 32 times. We have, oh wait, that's wrong. No, wait, it's not wrong. We have 6 left over. 6, 0, 12 goes into 65 times. I was right. I don't know why I second guessed it. And then that's going to equal, on this side, the 12s cancel, and it equals n-2. And now I just have to add this 2 to both sides to get that 27 is n. And what that means is that this cube that has 300 blocks with 2 painted faces is 27 by 27 by 27. Okay. What's the smallest cube that has 555 or more blocks with 1 painted face? So for this one, to do it the true way, we need a inequality. We don't want it to be equal to 555. We want what we have to be greater than or equal to 555. So we want 555 or more with 1 painted face. So that was our 6 times n-2 squared stuff. So what we'll do is we'll divide both sides by 6, and we get n-2 squared is greater than or equal to, and what do we got here? I need to start bringing a calculator. Okay, so 6 goes into that 9 times, and then we have 1, 5, it goes into that 2 times, and then we have 3, 0 goes into that 5 times. Okay, so it's 92.5, and now we must square, we must square root this both sides, which is a little iffy of a thing to do with inequalities. However, because we know everything is positive in our block situation, it's actually not so iffy right now, but I had to say it. So the square root cancels the square, and we have n-2, and that is going to be greater than or equal to. And the square root of 92.5, again, there should be a plus or minus, which then affects this stuff, but we're going to ignore the plus or minus because we know everything's positive. The square root of 92.5 is about 9.75. I totally remember someone doing this in class with their calculator, so don't be super duper impressed. I didn't do that in my head. And then now we add the 2 to both sides, and we get that the size of our cube, which is n, has to be greater than or equal to 11.75, which means that the smallest cube we can have is 12 by 12 by 12. Okay, let's keep going. We have a pattern with dots. I've looked at this pattern now a couple of times, so I'm gonna pretend that I haven't and show you what I first saw. So you guys, here's what I saw a lot of students do in class. I saw a lot of students go, okay, there's 6 in this one, and then this one has 6 and another 5, so this one has 11, and then this one has 18. They counted it, it was 18. I believe them. Actually, maybe I don't. No, I do. I believe them. It's 18. And then they went, okay, so the first difference here is 5, and the second difference here is 7. And then they found a second difference of 2, and they kept going that way to figure out the next and the next and the next. And you know what happened? It helped them get the first answer, but not the second or third or whatever. So I'm going to say, let's not do this, you guys. If all I was given was those numbers, I would do it. However, what we're given here is a visual pattern. So it'd be a shame for us to ignore the visual. The visual is going to help us a ton. So looking at the visual, the first thing I saw was this I saw a rectangle here in figure 1. And then when I looked at figure 2, I saw the same rectangle with this thing on top. And I tried to keep going with it. And once I got to figure 3, I was like, this sucks. I don't know what's going on anymore. So I went back and I decided to see if I can tell what the pattern is going from the third one back. So in the third one, what I saw, just looking at the third one, was a square and then these 2 dots on top. And then when I looked at the second one, I saw a square with the 2 dots on top. And then when I looked at the third one, I was like, oh no, this one, oh wait, it does actually have a square with 2 dots on top. So that's what we're going to go with. Our square here is 2 by 2. So it's a 2 squared with 2 dots on top. So plus 2. This one's a 3 by 3. So it's a 3 squared plus still just 2 on top. And this one's a 4 by 4. So it's a 4 squared plus the 2 on top. And now, if I want to know what's in figure number 4, well, I can imagine that it's a 5 by 5 square plus 2 on top. So that's 25 plus 2, which is 27 for figure number 4. And now let's keep it going. For number 5, they have started to make an equation that represents the situation. They want us to help them finish it. So all you really have to do is look at this and go, okay, here's the square part plus, look at that, it's a plus 2 every time. But I do want you to make sense of this part. I want you guys to be able to do this stuff. You can do it. We usually like to let n be our figure number. So here n is 1, and we had 2 squared. And then over here n was 2. We ended up with 3 squared, so 1 more. Over here n was 3, and we had 4 squared. Again, 1 more. And in figure 4 we had 5 squared, 1 more. It's always 1 more than what n is. So n plus 1, that's where that came from. It is squared and then the plus 2. And that's how they got it. Okay, awesome. Which function correctly outputs the figure number n in terms of the dots d? So for this one, we got to rearrange this equation here, all right? We're going to go with the d equals n plus 1 squared plus 2. You guys, we can do this with the visual way that they show us in the next section. Or we could just do this with the algebraic way. So I'm going to do the algebraic way real quick on this guy. So what happens is we first have to subtract that 2. So we get d minus 2 equals n plus 1 squared. Then we have to square root both sides to get rid of the square. And again, typically there would be a plus or minus happening. Oh, no. But in this case, because it's blocks and I don't want negative blocks, I'm not going to do plus or minus. And then I just have to subtract the 1. So what I get is that n is by itself, and it equals square root of d minus 2 minus 1. This minus 1 is not in that radical. And that's this one. Okay. All right. I am going to show you guys Desmos's visual way, which is phenomenal. But we're going to do a ton of that, I think, in the next homework. So let's just do it when we get there. Is there a figure with exactly 144 dots? Good question. Let's see. If I put 144 in for the d for the dots right there into the equation that we know is correct, the first thing I'm going to do is go 144 minus 2 and get 142 in a radical, which isn't a perfect square. So this is going to come out to be a decimal. And then I'm going to subtract 1. And what I'll get is basically an n value that's a decimal. If you want to solve it out to see it, go for it. But that means there isn't a true figure number, or else we would have gotten a whole number. So I'm going to say no. And I explained my thinking when I was talking to you guys. So moving on. Okay, you'll create your own pattern. Oh boy. Okay. Draw a sequence of figures using dots so that the following conditions are met. Each figure builds on the one before. The number of dots d in the nth figure can be represented by 4n plus 1. Oh, they got specific here. Okay, so let's see. In figure 1, we have something. That can be whatever you want. All right, now I'm not a very creative person. And I like keeping things simple, so I'm going to go with just 1 for figure 1. But you can, honestly, you could do whatever you want. Now, that means, oh wait, no, it can't. It can't be. Just kidding. Just kidding. Just kidding. Just kidding. It can't be, you guys, because in figure 1, n equals 1. And if this condition has to be met, then for figure 1, the number of dots I have needs to be 4 times 1 plus 1, because it's figure 1. So this is when n equals 1, or figure 1. And so that means that the number of dots I have has to be 5. So I could pick whatever I want to do as long as I have 5. So let's go with 3, 4, 5. I made a little flower or a plus sign or whatever you see. Okay, let's see what I have to have when n is 2. I need to have d be 4 times 2 plus 1. So d, in this case, is 8 plus 1, which is 9. Okay, and it needs to build on the one before it. So I have to take what I drew, and now I need 4 more. So I'm just going to 1, 2, 3, 4. Just keep it going. Why not? And then in figure 3, I think I'm going to get away with doing it again. D must be 4 times 3 plus 1. So my D must be 13. And so 13 is 4 more than the last figure. So I'm just going to go 1, 2, 3, 4. I'm going to go it this way, but honestly, you could have done so many things. How many dots will there be in figure 12? Oh, that's easy. I just got to plug in 12 for n. So D equals 4 times 12 plus 1. So D equals, in this case, 49. 12 times 4 is 48, plus 1, 49. And then which figure has 281 dots? Okay. Now D is 281. So 281 equals 4n plus 1, and I just work on solving this. Subtract that 1 first. This is a two-step equation. 280 equals 4n. 4n, I see no operational symbol. That means I have to divide the 4 because it's multiplication. And this is 70. Figure number 70. Rewrite the equation d equals 4n plus 1 so that n is in terms of d. No problem. We're going to do what we did here, but leaving d where it was. 4n plus 1. So we're going to subtract the 1. Just like we subtracted the 1 here, except now it's just going to be left d minus 1 equals 4n. And then now we're going to divide the 4 just like we did here to get that n equals that, d minus 1 over 4. Okay, there's a spiral review. It works on our equation rearranging skills. Like this one right here is pretty much exactly like this one that I just did, so I'm not going to do that one. Determine the original number. If you double this number, then add 2, the result is 18. I'll do it. This number is unknown. Let's call it n, okay? If I double n, so 2n, and then add 2, so plus 2, the result is, that means it equals 18. So then what's the number? We subtract the 2, we divide it. Do it yourselves, give it a shot, because it's just like solving this guy right here. The answer is 8. If you multiply this number by a third, then subtract 4, the result is 3. So again, this number is unknown. Let's call it n. Let's multiply it by 1/3. Let's subtract 4. The answer is 3. I will do this one because I bet a lot of you are scared of that fraction right now. And I just want you to see that it's not scary. Let's add the 4 to both sides first. That's still the first thing we take care of. Now, that 1/3. Whenever I have a fraction and I want to get rid of it, I multiply both sides by the reciprocal of this. Okay, reciprocal means flip it. Instead of 1/3, let's have it be 3/1. And then multiply the other side by 3/1. And what happens here is you'll see that your fraction cancels out completely. It just cross cancels itself out. And you have n equals. And on this side, you have 7. You can put it over 1 if you want. Or better yet, you could forget the 1. If it's a 1, you can forget it if that's what makes it look better. It's just 7 times 3, which is 21. All right? So, not so bad. Okay, we did it. Should we just keep going in one long video? Or should I make this one separate? I want to make it separate, you guys. I'm going to stop this video, start a new one.